Everybody has been made well aware of the opioid epidemic in the US, correct? In 2017, in the US, approximately 30,000 people died from overdosing on synthetic opioids, 19,000 from commonly prescribed opioids, 16,000 from heroin, and so many more. Now you may be asking yourself, what exactly causes addiction? How it works is your brain creates natural endorphins, which make you feel happy. Opiates create artificial endorphins, which prevent the brain from making natural endorphins. Once the users are off opiates, all the endorphins go away, which make you feel depressed. Now, once artificial endorphins stop being sent to the brain for a while, aka recovery, then the natural endorphins can start being produced by the brain again, and it's all better, right? But what if a person is taken out of recovery and begins to use large amounts of opiates again? It is too much for the brain to handle, and that is what causes overdoses. Due to the increased amount of deaths from lethal side effects of morphine and other opiates, there has been an increased amount of opiate awareness campaigns, which resulted in the creation of an experimental drug called PZM21. Unlike morphine, PZM21 is more effective with the affective component of the analgesic rather than the reflexive component that causes respiratory depression and the addictively known side effects. Now, how opiates work is this. The opioid system contains 3 G protein coupled receptors, which are the mu, delta, and kappa. These receptors are stimulated by 3 endogenous opioid peptides, which are enkephalins, dynorphins, and endorphins. However, the 3 opioid receptors can also be activated by alkaloid opiates, which are drugs like morphine. PZM21 is an experimental drug that can disentangle the mu receptor signaling and is used for therapeutic purposes. PZM21 is still an opioid medication, but the chemical structure of the molecule is designed to target very specific opioid receptors, so it acts differently from other prescription painkillers. PZM21 hits the mu receptor for analgesia, but does not work well with other receptors that release the chemical beta-arrestin, which leads to the euphoric behavior that addicts seek. Laura Bone, one of the lead researchers into the effects of beta-arrestin, found that mice who were genetically modified to not produce beta-arrestin did not act intoxicated when given morphine to kill pain, and they did not crave morphine as normal mice did. They also did not suffer respiratory depression or constipation, which are the 2 most common side effects of the current opiates. PZM21 so far has been the most promising compound that does not activate beta-arrestin. Along with that, there's appeared to be less euphoria when taken, and thus far does not trigger addiction. Trials in mice and primates show that both mammals, when given the drug, did not seek it out. However, there is no indication when PZM21 will work in human trials, and substances like this are not yet on the market because their long-term risks are unknown. It is also still possible for some people to begin to abuse it, and it could have other serious effects on health which are not yet understood. But for the meantime, with the current opioid crisis, PZM21 is the only real hope, and it could potentially save hundreds of thousands of lives.